So we'll find the derivative of cosine of theta. Now, when I made a video for finding the derivative of sine of theta, it took about 10 minutes. So you have to go through the whole definition of derivative with limits. And if you can do that for cosine too, it'll work. But I'm going to leave that to you to do on your own time because I have a faster way to do it. So we'll take a look at that here. So what is cosine of theta? What is cosine? Cosine of an angle means sine of its complementary angle. So we can write this as the derivative of the sine of the angle complementary with theta. Well, what does it mean for an angle to be complementary to theta? That means that theta and its complementary angle have to add up to pi over 2. Don't say 90 degrees. I will throw a fit. So I need an angle that when I add it with theta, it will give me pi over 2. And the answer for that is pi over 2 minus theta. Because if I take pi over 2 minus theta and add it with theta, I will get pi over 2. And we know how to find the derivative of sine of an angle now. We know that that will be the cosine of the angle. But don't forget the chain rule, multiplied by the derivative of the inside function. What's the derivative of the inside function? Well, the derivative of pi over 2 is just 0, and the derivative of theta is just 1. Now, what is cosine of pi over 2 minus theta? Well, again, the cosine of an angle is like the sine of its complementary angle. So what angle is complementary with pi over 2 minus theta? Well, obviously theta is complementary with pi over 2 minus theta. But then don't forget this right here. 0 minus 1 is negative 1, so we have to multiply this by negative 1. So here's our derivative for cosine of theta. It's just negative sine of theta.